Okay, we are doing the tech section. So this is section 7.2 to 7.4 with technology. So there will be 3 separate programs, and each program is going to give you is a p-value. And here's how you're going to read your chart. If the p-value generated by the program is less than or equal to the given alpha value, you will make the decision to reject the hoe. And then you follow your little flow chart. If the p-value that the program gives you comes out greater than alpha, then you're going to fail to reject the hoe. So you still need to write down the claim, the hoe, the ha, and you're going to be writing down your values that you're putting into the program and giving me the program name. So I do have all of the examples all typed out for you. So we'll just go through and decide which program you're supposed to use. And the programs, there's 3 of them. Your programs are because we're doing hypothesis testing, we're going to call them the z-test, the t-test, and then the one proportion test. So each one parallels the 3 sections we've done. So we'll start here. It says the number of years it took a random sample of 32, so N is 32, former smokers to quit permanently is listed. Alpha is 0.05. Test the claim that the mean time it takes smokers to quit smoking permanently is 15 years. So we're going to write the claim just like we did for the by hand ones. This is about the mean is 15. That makes that the hoe. So the ha is not equal to 15. And then I took the time to type this into 1-bar stats, and I did give the mean. I gave the S and the sigma because that's what 1-bar stats gives you. And I want to talk about which one you're supposed to take. Well, remember I said the calculator doesn't know what you put in, whether you put in a population or a sample. This is a random sample of 32 smokers, so you need to use the S, not this. So now we are ready for the program. So I'm going to switch over and show you how to use it. And there's going to be 2 links in the classroom. One link is for the Z and the T together, and then the other one is for the proportion one. So if I come over here, I do have them opened up. And like I said, they're linked in Classroom, but I will just go to what I have open. And I want the one that has mean right here on this window. And this is the same page that we used before. So you can see hypothesis test for a population mean given statistics calculator. Now, I wish the programmer had done this a little bit differently. This says sigma unknown or sigma known. I wish this had said T or Z. Because for you, we know that this is, because the sample size is 32, we want this to be a Z. So if you look on this screen right now, it says T down here, and it's T when you have the sigma unknown checked. With sigma known, it switches to a Z. Even though we don't know this sigma, like I said, I wish he had labeled these differently. So just pay attention to which one's clicked and then look down in the box here to see whether it's Z or T. I know I want a Z, so I'm going to have this bottom one checked. So now we're going to put in the S value, not the sigma, because we technically don't know that sigma. The S was 4.288. That's the tricky part here. This asks for sigma, but you have to put in the S. The sample mean is not a problem, 14.83. The N was 32. Remember the mu0 is from the whole. What's the mean from the whole? The whole is a mean 15. And then over here, you have to pick your ha sign. Does your ha have a less than, greater than, or not equal to? When I look back, it's a not equal to. So notice that all three of these are the ha signs, and then just hit calculate. The only thing I want is the p-value. So the p-value is 0.823. And like I said, now we're ready to make our decision. And according to the notes, the p is 0.823. The alpha was 0.5. So the p is definitely greater than the alpha. So when it's greater than the alpha, we fail to reject the hope. And then you can use your little chart or the poster in class. And if you follow it down, claim hope, fail to reject, that's a NEEF. There's not enough evidence to say that that claim is false. So I'll go through another one with the programs. Just try to keep clear whether you're putting in S or sigma. That's why I crossed it off. You cannot use that value even though the program is asking for it. Oh, here's me writing on a paper and you guys aren't even on it. I'll never figure all this out. I'm going to go back. Sorry. I'm going to do the best I can here. Switch. How do I switch back? Stop presenting. Oh, I wonder if it showed it over here. Oh, was it on there double? It was only a single on mine. All right. So, sorry, I don't know what's going on here, but I wrote down the p-value. I compared it back to the alpha of 0.05. 0.82 is definitely bigger than 0.5. And according to the notes that I gave at the beginning, if p is greater than alpha, you fail to reject the hope. And then looking at the poster, NEEF. Let's try another one. I can stop presenting again, make it bigger. There we go. Second one. So as a part of, I should have put Z here. As a part of your study on the food consumption habits of teenage males, you randomly select 20 teenage males and ask how many 12-ounce servings of soda they drink per day. The results are listed below. At alpha equals 0.05, is there enough evidence to claim that teenage males drink less than 3.0 12-ounce servings per day? I'm assuming that's an average. So the claim is that the average is less than 3.0, making the claim the ha. The ho will be it's actually greater than or equal to 3.0. I put these into one of our stats, wrote down all three values, the mean we have to use. Which one do you want, S or sigma? And this was a sample of teenage males, so do not use that value. No. All right, so now we've got to decide, is this a Z or a T? And I did give the population is normally distributed. Because the sample size is small, with the population normal and the S, that makes this a T. So now we're going to go back to that exact same web page. So let me present that. I want the mean one again. I want this down here to be a T, and I get that by switching this up here, which standard deviation is known or unknown. Like I said, I wish this was Z or T here, but it's not. So when I click the top one, I get the T. So just replacing the values, the S is 0.828, 0.828. The mean was 2.785. The N was 20. And from the whole, the mean is 3.0, or just 3. The ha sign, don't forget to click this over here. Ha has a less than in it. And then it's calculate. And again, it's the p-value we want. So I will stop presenting. It's p equals 0.130. So come back here. We will stop presenting. P equals 0.130. Again, we compare that to alpha. So I got 0.13 and 0.05. So again, P is greater than the alpha. 0.13 is greater than 0.05. So I have the same conclusion that I did there. Fail to reject the whole. But because now my claim is the ha, I have a different conclusion. I have neat. There is not enough evidence to say that that is actually true. Okay, next one. 34. Well, must have been from a problem page in the book. It says an Alabama politician claims that the mean annual salary for engineering managers in Alabama is at least the national mean of $69,000. So here's our claim. Make sure you're getting symbols right. It's about the mean is at least, that's greater than or equal to 69,000. Making the claim the whole. So our ha is less than 69,000. Okay. We have a sample size of 9. That is a small sample, which is normally a t-test, but if you look at that flow chart from the last chapter, if the sample size is less than 30, you have to be given that this is normally distributed. And nowhere in here does it say it's normally distributed. So with a small sample that's not known to be normally distributed, it's not possible to do. So big samples, you don't have to be told it's normally distributed. Big samples are just automatically, you go with it. Small samples, you have to be told it's normal. So if you don't have both things, you can't do it. Big samples, no matter what. See, look here. 32, nowhere in here did I say it was normally distributed because it doesn't matter. Once it's 30 or more, you just do the problem no matter what. Okay, so I think you know what's coming on this last one. It has to be the proportion one. The claim says less than 60% of Americans are overweight. Okay, so we'll put that into symbols. Because we're talking about a percentage of the population, we're using P, not the U, is less than 60%. That makes the claim the ha. So the ho will be greater than or equal to 60%. Sample is 35. 58% are overweight. So P hat is 0.58. Tested at alpha equals 0.1. Okay, so if you follow the steps for the proportion section, you do have to check to make sure your sample size is big enough. Let me get to that. And remember that that is n times p and n times q both have to be greater than or equal to 5. So n was 35. So we're checking for sample size before we can even get going. So 35 multiplied by the p, big P, not the p hat, is 0.6. So 35 times 0.6 is definitely over 5. So then 35 times, the Q would be 0.4, because those have to add up to 1. 14. We're okay to go. If the sample size is big enough and we're with proportions, we know that this is a Z, but that'll show up in the program. So we're going to go to the proportion program, and I have a separate link for that one. So I'll go back, present now. Here's the proportion one. Share. And if you look, it's number 29, hypothesis test for a population proportion calculator. If you look, it's telling you what to put in, sample sizes and the number of successes in your sample. So we know N is 35. I did not give you the X. I gave you the percent of successes, 58% successes. So now I've actually got to multiply 0.58 times 35 to get how many successes I had. So 0.58 times 35, I got 20.3. So I have to put in a whole number here. I'll probably get an error. So I'm just going to, it rounds to 20. So it's normal rounding rules. Now the percentage from the whole as a decimal, I believe. I'm assuming it's a decimal. 0.60. Over here to the left, again, you need the ha sign, which is a less than. That's selected. Now I just hit calculate. And what I want is this p-value over here. So 0.365. So stop presenting. 0.365 was the probability value. And we're always comparing that p-value to the alpha. So this one, same thing I've had all day here. This probability is definitely greater than alpha. So that is fail to reject the hoe. And that makes the not enough evidence to say that claim is true, when the claim is the ha. So it's a neat. So what I want to see on your technology ones, I do want to see the ho and the ha and the claim all identified. That has to be there. On a test, you're going to have to tell me the program name. So I would prefer the program name and just use z-test, t-test, proportion test, the p-value, and then your final two-part answer. So you don't have to write down all this mumbo jumbo in here, but I want the claims, the p-value, the two-part answer, and the program name, please. So not the URL, the program name. T-test, Z-test, proportion test. All right, that's all I've got.